Number 14, solve for x and y. And now we have this equation. There was a typo. There's supposed to be a 1 equals right here, where we have some imaginary numbers. This says I is equal to the square root of -1. And if you remember about imaginary numbers, the only real difference between them and any other variable is that they cannot have exponents. Okay, like there's like a cycle that we'll get to in a bit when we solve for y. But we are supposed to solve for x and y, which means get x and y by themselves. But there's another little stipulation. We want this to be in complex number form. That would be the real number, a, plus the imaginary component number, bi. Okay, so without further ado, let's get started and get the x by itself. Both of these problems are going to start the same way. We are going to multiply both sides by 3 minus I. That way, this is not a fraction anymore, okay? And so whether you're solving for x or y, that's something that's going to have to be done. So I think I'm going to just go ahead and do 1 times 3 minus I and get 3 minus I equals 8 plus x plus 11 plus y times I. And I'm going to go ahead and copy this and save this part of the problem for when I'm solving for y over here in a second. All right, so if I'm going to get the x by itself, I need to get this entire chunk of stuff that's not in this parentheses. I need to get that to the other side. So the first thing I'm going to do is I'm going to subtract the 11 plus yi on both sides of the equation. Okay, that's going to give me, and I'm going to go ahead and distribute the I, and I'm going to distribute the negative sign. I'm going to have 3 minus I minus 11I minus yi equals, and then I can drop the parentheses if there's nothing being distributed. I don't have anything multiplying by this, so I can just drop it. 8 plus x. And then just to get the x by itself, I'm going to subtract the 8 from both sides. Doesn't matter where I subtract it over here, but I will go ahead and combine my like terms. So I've got 3 minus 8. Those are both real numbers. So that's going to give me -5. Negative 1i, there's an invisible 1 here, right? Negative 1i minus 11i would be negative 12i minus yi equals x. And then the last part of putting this into the complex number form is to just go ahead and factor the I out, and I can write my answer as, I'll go ahead and do it up here. Just note that I'm going to be factoring this I out as a greatest common factor here. -5 minus 12. You know what? We're gonna put this in standard form with the variable in front. I think that's better. And you know, I'm gonna go ahead and factor out the -1 as well. I think it'll look nicer that way. So minus y plus 12i. Okay. And now let's go ahead and do the same thing, but this time find our y value. So in order to do that, I'm going to have to subtract the 8 plus x from both sides. I'll go ahead and distribute the negative sign. I'll go ahead and distribute my I as well when I rewrite this equation. So this would be 3 minus I minus 8 minus x equals 11i plus yi. All right, and now to get the y by itself, I have to subtract the 11i. I will go ahead and combine my like terms while I'm at it. So the 3 minus the 8 is -5 again. The negative I and the negative 11i is -12i again. Minus x equals yi. And this is where I have to get rid of this imaginary number over here on the y, and I'm going to do that by dividing both sides by I. And I can rewrite this. There's going to be a little bit more of a step than what we had before, but I can rewrite this as -5 I to the -1 power, because we're dividing by I. That's what a negative exponent means. On this term, the i's will cancel, so it'll just be -12. And then on this term, I'll have negative xi to the negative 1 power equals y. So we have y by itself. We just have to put this into complex number form. And if you will recall, I'm going to go back over here, the exponent rules for the imaginary number. If you have an I to the first power, it's I. Second power is negative 1, as per the definition. Third power is negative I. Fourth power is 1. And then it just repeats over and over again, like fifth power, sixth power, seventh power, eighth power, ninth power, 10th power. You get it. You can also go backwards. So if this is the first power, this is the 0th power, because everything to the 0th power is 1. And then the negative 1 power is just negative I. So I can actually use this. I to the negative 1 power is just negative I. So this is going to become positive 5I, okay, minus 12. This will become positive x, and that's equal to y. And then I just have to put this into the, sorry, forgot my I. That I just have to put this into complex number form. That's going to be the negative 12 is my real number. And then I'm going to go ahead and put these guys together and factor the I out, just like I did in the previous problem. So that's going to be x plus 5, and then the I is going to be on the outside. And these are the answers. I know it's a really weird problem, but it's really not very difficult math once you get used to it. So maybe watch the video a couple times, and that's it.